I am really excited to introduce our speaker today. Our speaker today is Isabella Velasquez. Isabella is a coworker of mine, so I'm really excited to have her here. But I am always impressed with Isabella's work, the quality of her work. So Isabella is an art enthusiast. So she first learned about R during her master's degree in analytics. She has a background in data analysis and research, infrastructure for people who are data analysts, and trainings and resources. So she now works at Posit, which is also where I work, on the marketing team that to make like content and blog posts and all these things that really help people learn about how to use R for data analysis. So I am really happy to welcome you, Isabella. Thank you for coming. And when you told me about the kind of talk you wanted to give, I thought, oh, that's perfect for this group. So we're really looking forward to having you here. Thank you so much for preparing. As you maybe get your screen shared and unmuted and all that, we have a couple of options for questions. You can type questions into the chat. And also we have the Q&A set up. So you can, if you choose the Q&A option at the bottom, you can also type a question there. So Andrew and I will both keep an eye on these. We'll probably keep the questions to the end unless something really dramatic happens. So we will, we'll please, as if things occur to you during the talk, go ahead, ask them, type them, and then at the end we'll go through and we will see what we can do. So let's go for that, for questions. Awesome. All right. How are we doing, Isabella? Looks good.
Good. Thank you so much for the introduction. Can you see everything all right?
Yes.
Okay, great. I'm about to enter full screen, so
Okay.
I don't think I'll be able to see Zoom anymore. But again, thank you so much for the introduction, Julia. Thank you, Julia and Andrew, for having me. And thanks all so much for coming to join and talk about 7 essential Excel data visualization tips in R. And Julia just introduced me, but just a really brief recap. I'm a senior product marketing manager at Posit, formerly RStudio. In my previous role, I worked as a data analyst on a team that mostly worked in R. And before that, I worked as a survey specialist at a research organization that was very Excel and SAS heavy. So just wanted to give a brief background on the sort of tools that I have used in my career. I live in Seattle and have used R for many, many years. I'm a co-organizer for Our Lady Seattle. So if any of you happen to be in Seattle, please reach out. I'd love to chat. And in my spare time, I love traveling and hanging out with my cat, who you may have seen is sleeping behind me right now. So I wanted to briefly talk about the inspiration for this talk, and I apologize. I realize it's not showing up, but I spend a lot of time on Twitter. And a few months ago, I was on Twitter and noticed a tweet that got over 10,000 likes, and it was talking about 7 essential data visualization tips for Excel. And, looking through it, I was like, oh, this is very interesting. I wonder if you could do this in R. And then after that, I kind of stopped thinking about it until Julia reached out about this opportunity. And I was very excited to be able to dedicate the time to think about, like, if I wanted to do these Excel visualization tips in R, how would I actually go about doing it and showing others how to do it? So really excited to talk about that today. And another inspiration for today's talk is, as I mentioned, I used to work at an organization that was very Excel heavy. And at the time, I was getting my master's degree and learning R. And so my workflow ended up kind of looking like this. It was a mix of Excel and R, pulling data from Microsoft Access. And some things I would do in Excel because I knew how. I wanted to try my hand at R, so some things I would pull into R and do a little bit more complex data manipulation or analysis there. But ultimately, I always had to bring stuff back into Excel to be able to share it with my colleagues and my manager and finish up the analysis, anything that I didn't know how to do in R. And then finally, output everything into what we would eventually share with our stakeholders, whether that be PowerPoints or PDFs or emails or Word documents, etc. And this workflow worked, but I will admit it was very error prone. For one thing, everything was a little bit disjointed. So if something changed in the upstream Excel file, I had to make sure to also change it in the downstream Excel file and the final outputs. And so, if there were any sort of gaps along the way, something could be missed and incorrect information could be sent through. Another thing, it was very manual to create these final outputs. It involved a lot of copy and paste and formatting. And if you've ever pasted an image in Word, you know how like detailed you have to be in exactly placing it and the size and everything like that. And then finally, it was just thinking about like how best to do this process as my R skills developed and I added to my toolkit. When I moved on to the next position as a data analyst, I was able to kind of collapse all of that workflow into just R. So R was the mechanism in which I would pull data, work with data, create, the things that I needed to do, either the analysis, the visualization, the tables, and then directly output into the things that I would share with my team. And so that's another inspiration for this talk. I believe Excel is a fantastic tool, R is a fantastic tool, but the more things that we're able to combine and pull together, it just gives us more options for being able to create things that are great and engaging and resonate with the people that we're talking to. And I think it is always worth taking the time to add to your toolkit in this manner. So what are these 7 essential Excel data visualization tips? The first one is an image bar chart in which you have a bar plot, but instead of showing the bars as a filled rectangle, for example, instead you show them as images, usually representative of the thing that you're talking about in the data. The next thing is a geographical heat map, sometimes called a choropleth map. And so in this case, values of numbers or quantities are reflected on specific geographic areas and demonstrated as they would show, on a map that is printed. And the different colors represent different values of that data. The third thing is color scales. So being able to show a grid in which, again, the color represents the number or the quantity, or et cetera, and being able to represent information in this manner. And this is also sometimes called a heat map. Spark lines. So spark lines are small, minimal representation of variation over time. So in this case, things like visitors over time with like as few information as possible to just really relay something like a trend or variation. And these are often shown in like financial plots or newspapers, places where space is kind of limited. The next one is called the rep charts. And these also go by unit charts or dot charts. And the idea is to show discrete quantities in individual circles. In this case, it could be squares or whatnot to represent each unit by itself, as opposed to aggregated as it would be like in a bar plot or something like that. Next is data bars. And so in this case, it's putting numbers and data together, usually in a table, and being able to put both sorts of data together, visualizing it, and also providing the numeric value. And finally, icon sets. So being able to show change over time, rank, etc., through an arrow or some other kind of icon directly within your table. And just making sure I'm not missing anything. Okay, so in terms of the tools that we're using today, while I was preparing for this talk, I have to admit I was a bit overwhelmed. So the R programming language is enormous. There are so many amazing packages and tools available for pretty much any sort of creation or analysis or output that you want to create. And packages in the R world are collections of commands that help you do something. So whether that is calculate something, model something, plot something. And so as I was thinking through how I wanted to approach this, for each one of those tips that we just saw, there really are multiple options for creating them. But today we're going to focus on two particular packages. One is ggplot2, which is a package for creating charts and plots using the philosophy of the grammar of graphics, in which we'll talk about in a little bit. And then the second one is GT, which is a package for creating tables using the components that make up a table. And the reason that I wanted to use these two packages today were twofold. So first of all, both of them have similar philosophies in terms of how to create the output that you want to create. The idea of starting with your data and then layering on piece by piece, step by step, everything that it is that you want to your final output to look like. And that helps in terms of keeping track of exactly what you're doing, really adding the details that you're looking for, and really being able to dig into customization. And the second reason that I wanted to focus on these two packages is they are open source packages. And because of that, first of all, there's a huge community behind them. And in addition to the packages themselves having a ton of functionality, they are highly extensible because they're open to anybody. So if there is a plot that you can dream of, if you can code it, you can create a package that extends ggplot2 or GT. And that way you can create the sort of chart you're looking for, you can share it with others, and others can build upon it and keep adding to it. And so we'll see later on today, we'll be using a few of these extensions to create those sort of charts that we saw can be done in Excel. And just to really highlight the examples, we're going to be starting off with kind of fundamental understanding of both ggplot and GT, but really it's amazing what can be created. At Posit, sometimes we held a table gallery, or sorry, table contest last year, and the submissions were absolutely inspiring in terms of how people use GT and other packages in the R ecosystem to create really visually stunning tables. And also, along with ggplot2, it's really amazing, like the things that folks have created using these packages. So we're going to start off by talking about ggplot2. Like I mentioned, ggplot2 is a package that creates charts using this idea of the grammar of graphics. So building plots step by step until you get the output that you're interested in. In terms of how to start with ggplot2, first you set up your plot with ggplot, then you add your data. Next, you specify the variables within your data that you're interested in plotting with aesthetics or AES. Next, you choose the chart type that you're interested in with Geom. And like I mentioned, there are a ton of Geoms that are readily available in ggplot2. There are a ton available with other packages as well. Next, you add new layers one by one using a plus sign in between them. And this helps you add elements to your chart that make it look the way that you'd like, as well as themes that you can add onto your chart and really help customize it and tweak it and make it, exactly what it is that you would like to output. So let's do a really rapid introduction to ggplot2. First, we're going to set up a plot in R to let our script know that we want to use the package called ggplot2. We call it within a function called library, like so. So we're letting it know, hey, we'd like to use ggplot2 here. And then we set up our plot. In this case, we start with ggplot. We put our data, which is held in CI_NP. Then we define our aesthetics. And so here we're saying we want year on the x-axis and visitors on the y-axis. And then we specify our geom. In this case, we are saying we would like a line graph, and therefore we would use geom_line. Like this. And by doing so, we get our first ggplot. So say we want to customize it a little bit. We want it to look a little bit different, specifically want to change the color and the type of line that we're using in this chart. So we can add that to geom line. Here we're specifying a color that we want, then the line type that we want. And by running that, we get exactly that. A line chart that is dashed and using that kind of blue color instead of black. All right. Let's say I don't really like that background. It's gray and so it's kind of hard to see the line. And so here, this is where the theming that I mentioned comes in. You can keep adding to your plot to make it look like the plot of your dreams. So here we'll add theme minimal, which is a theme that comes bundled in ggplot2. It's my absolute favorite theme. And adding that, here we go. This is our new plot with that theme as a background. So again, you just keep adding and adding until you get the final output that you need. Say we thought those labels for the X and the Y axis and the title are missing. And so it would be good to like specify what we want. So you can add them using labs, specifying X, Y, title, and subtitle. And we have the image that we're looking for. Something to note is the ggplot2 package is part of the Tidyverse collection of packages. The Tidyverse is an opinionated set of packages that work with what is called tidy data. And tidy data is a specific structure of data in which each variable is a column, each observation is a row, and each cell is a single measurement. And so oftentimes we get data in this wide format, as you can see on the left, in which a row has multiple observations, one for each year, 2012, 2013, 2014. However, we want to take the time to go ahead and make this into a long or a tidy format, as you can see here on the right, in which each observation is its own row. When I first started out in data science, I did not realize this. And so oftentimes I would try to make my wide format data set work with ggplot2 and would be very confused as to why it wouldn't work. And now I know why. So I just wanted to point that out, that it is very much worth the time spent at the beginning of your analysis if you plan to use ggplot2 to go ahead and make your data into the tidy format much easier down the line. Next up is GT. Like I mentioned, GT creates beautiful looking tables using the components of a table being added one by one and constructing your ideal along the way. So here are the parts of the GT table. So again, the philosophy is kind of like every table, if you want a table header, you would add it here. If you want a stub head, you add it here, a footnote, etc. And it's just a very, very flexible and way to progressively create tables. You can keep track of what exactly you're working on, and just highly recommend in terms of being able to easily construct fantastic looking tables. And so to get started with GT, again, we call the package by putting it in library GT. And then we give it the GT function, our data, in this case, CI_NP. Running that already gives us a pretty nice looking table, as you can see here. And if we want to keep customizing it, similar to ggplot2, we just keep adding the components that we want to add and tailor, etc. So we want a table header. We use a tab header to add table and subtitle like so. You may notice here, we're not using a plus sign, we're using what is called a pipe. So a pipe expresses a sequence of operations. We'll see a few examples of this later on as well. And so the idea behind a pipe is that it passes output from one function to the next. So in this case, it's saying take this GT table made from CI_NP and pass it to tab header. And you just keep doing that in GT, can be because it works with pipes. So say we want to keep adding to this, again, we can just add another pipe and say we want to format the number of visitors so that it has a comma every 3 spaces from the right. And so by adding format number, we can say in the visitors column, please add separators and don't add any decimals like so. And in addition to adding to the table, formatting the table, you can also do things like add colors to the table. And again, the GT package, it's really incredible. There's so many different functionalities that you can go check out the documentation and visit in terms of the things and how you can really construct this table just using the GT package. Like that. Okay, so thank you for listening to this brief introduction. And now we can actually get into the 7 essential Excel data visualization tips in R. So first, we're going to talk about an image bar chart. This is from the tweet. And you can see here in Excel, what you do is you drop and paste the image into the chart to have it represent the data that's shown on the left. So how do we do this in ggplot2? First, let's start off with our data. So empty cars is a data set that's built into R. And looking at it here, you can see that it has a variety of variables about these cars, things like miles per gallon, cylinders, horsepower, etc. And like we mentioned earlier, to start off with a plot, we say ggplot2 to set it up. We put our empty cars as our data. Our geom is geom bar, and then CYL, our cylinder, is our X data set or data point on their X-axis. We want to customize it a little more, so we can go ahead and add something called fill. So fill in particular is saying that we want to fill each of these bars representative of the cylinders that they are. So a different color for 4, for 6, for 8. And for a cylinder in the empty cars data set actually comes as a numeric variable. So first we have to convert it into what's called a factor so that they're discrete values that ggplot knows how to work with. And we could do that directly in here. Also notice that fill is contained within aesthetics. The reason because we are referencing our data set to be able to fill this graph, and therefore it needs to be within aesthetics. And then say we want to do something like add a border that's not referencing the data at all. We can add color to geom bar, but this time outside of the aesthetics, and then say, we would like a black border, so color equals black. Like so. And then just to continue customizing it, we'll put a minimal theme again and a label for the title. Like that. Okay, so say we want to create these image charts instead. So instead of using a fill like we saw last time based on the data, we would like to kind of customize it to look a little bit different with patterns or images, etc. So that's where GG pattern comes in. So here's an example. It looks like a lot, but we'll go through. It is the same code as we had just seen, but a few things have changed. So first off, we call GG pattern the package. Instead of geom bar, we say geom bar pattern. And then instead of fill, we say pattern fill, but it remains the same as vector cylinder. And then we also specify the kind of pattern that we want. In this case, we want a stripe pattern, so we say pattern equals stripe. And you may notice also there's a fill outside of aesthetics. This is to represent the fill of the bar rectangle itself, as opposed to the fill of the pattern. And here is our output. So now we have a bar plot And for cylinders, each cylinder has its own pattern from ggpattern. So that's great, but what if we want an image instead? So ggpattern has that option as well. Here, instead of pattern equals stripe, and we are using pattern equals placeholder because the package actually comes with placeholder images. And because there are multiple options, we want to say pattern type equals kitten to specify that's the kind of chart that we want. And then we get a chart with cute little kittens as images within each of the plots, or the bars, I'm sorry. All right, that's great. So what if we want to do what we saw in Excel? We want specific images that we are choosing instead of placeholder images. So there, ggpattern has that functionality as well. So first thing, we need to specify the specific images that we want to use in our plot. And here I have them as logo 1, logo 2, logo 3. And then instead of pattern equals placeholder, we're going to say pattern equals image. And pattern type specifies how we want that image to be placed within the bar, like the bar rectangle. There are some options that just place the image in respecting aspect ratio, but we're going to go with squish, which doesn't respect aspect ratio so that it fits within the whole rectangle of the bar plot. And then we also have to specify what our data, what logo to use with each one of our data points. So cylinder has 4, 6, and 8 as options. So we're saying that we want 4 to be logo 1, 6 to be logo 2, and 8 to be logo 3 using scale pattern file name manual. And you may have noticed this new addition, alpha equals 0. So alpha specifies the transparency of our geome. So for example, if you have a scatter plot with lots and lots of dots, and it's kind of hard to see where some dots are concentrated, you can lower the alpha so that there's a bit of transparency there, and so it's easier to see. And so because this is the alpha for the rectangle of the bar plot, we don't want that to show. So we just specify alpha 0 to make it fully transparent. And with that, we have our image bar with ggpattern, looking like the one that we saw in Excel. Okay, next I'm going to talk about geographical heat maps. And these are also known as choropleth maps. So you can see there's data on the left. It corresponds to each state corresponds to some sort of sales data, and that is plotted on an image of the United States. The darker the color, the more sales from that particular state. So how do we do this in ggplot? So here we're going to add a couple more packages that we haven't used yet. First off, we're going to use dplyr, which is a package also in the Tidyverse collection of packages. And the reason that we want to add this is that dplyr is used for data manipulation and wrangling. And it's going to become important in a little bit. Next, we're going to have ggplot2 again, but this time we're going to add another another package called maps. And maps is an incredibly powerful package. It has a lot of data related to mapping, not just the world, but also states and countries. And so for me, like, this is my go-to way for creating any sort of map. First off, we need to access the world data by using the function map data from maps. So here we're saying use map data to grab the world data in the function and then save it in an object called world map. And taking a look at that, you can see it has these columns of longitude and latitude attributed to a certain place in the world. So we set up our ggplot. We add our data, which is in this case is world map. And then we have a few things that are special to geom map, which is our new geom. And so in this case, we're going to say map is world map, and also specify longitude as our X and latitude as our Y axis. And then we also have to give it the ID so it knows how to create the plot of the map of the world. In this case, we're saying we want the ID to be region or country in this case. And doing that gives us our world map, very first world map. So that's great. What if I wanted to, again, customize it, make it look a little bit like my own? So like before, we can just continue adding because this is a ggplot object. We can say we want like color and size and fill of the borders that are not reliant on the data, therefore they're outside of aesthetics. We want theme void, which is another built-in theme, which takes away things like the legend and the lines of the map. And doing that gives us a different map with blue color and white borders, etc. So this is all great, but how do we map it with data? So this is where the dplyr package comes in that I just mentioned. And so just a quick aside, if you haven't heard of Tidy Tuesday is a weekly social data project. And every week, a new data set is released for everybody to jump in and create a plot. And really, the world's your oyster. Like whatever you want to create with Tidy Tuesday data, you can. And it's, again, it's just another inspiring place to look at for how people are using all of these different packages in really, really incredible and creative ways. And I just wanted to provide this this week. It just so happens that it is World Data on Energy. And I wanted to provide the script in case you wanted to go ahead and do Tidy Tuesday this week. What you can do in order to clean up the data to merge it to the maps data that we just saw. So joining here, we have the world map data on the left. We have the energy data on the right, and we want to join it by saying, by combining the two tables by an ID. In this case, the region column from the world map data with the country column from the energy data. And that's what all the data manipulation in the previous slide was about, because otherwise they wouldn't join correctly. But doing that gives us the opportunity to use that data, which is saved in world energy in our ggplot. So here we have world energy as our data and under map. And then under fill, because we're referring to our data, this is under aesthetics, we're saying fill it by per capita electricity, that column that it's available in the energy data. And doing so gives us a map like this. And so that's great. We have created our geographic heat map. But again, there might be things you might want to tweak. For me, a couple of things. First of all, the background. And then second of all, there's very little variation in terms of the different colors of per capita electricity. And so one way to remedy this is using a log scale for that. And so we can just keep adding to it. And really, that's the point that I wanted to have today, that with ggplot, you can be really, really creative. You can bring in other libraries. So MexBrewer is a package that has palettes inspired by a lot of art from Mexican history. And doing so, we can really start making our map our own. And just really quickly, I'm assuming a lot of folks here are from the US. If you're interested in a US-centric map, you can also use the maps library, package, and then instead of map data world, map data state, and use that to start creating your map and customize it. And I pulled the same data, but for the US, just to show you can create another map similar to the world one, but for the US. Next, I'm going to talk about color scales. And so these are also sometimes called heat map. And so this shows a grid of information colored by the value of the data that that's underlying it. And so red could be lower, green could be higher in this case. So another data set we're going to use, and my cat decided to join us, is US personal expenditures. And so this is, as you can see, the expenditures in various different categories over several years. And so here we're going to create a heat map with ggplot2. And first off, as you may have noticed, that data was in wide format. We want to change it to long format. So this is the data for doing so. And then we could create our heat map. And we're going to introduce a new geome, this time geome tile, to be able to do that, since heat maps are grids pretty much. And then we provide a scale fill gradient to say, this is our high, this is our low. Please create a heat map with these colors. And doing so, we get our first heat map. And you may notice, again, there are a lot of things to customize here. It would be nice to have the numbers for one to represent, what is low and high if somebody hasn't seen this map before, or I'm sorry, this heat map before. And real quick, I just wanted to show as well, similar to what we've seen with the map, with the bar, you can continue like stylizing the way that you'd like, adding a border, adding theme, and so. And so the idea behind ggplot, like I mentioned, is that it's layers upon layers, building on the kind of map, that the plot that you want. And so here we have a geome tile. We want text as well. We can add that using another geome called geome text. So adding on top of our tiles, adding text, and just continuing to build upon our chart. And in this case, we're going to say we want a label that is the dollar of our expenditures. And because we're referencing our data, this is contained within AES as well. Scales is a package that has great functionality if you want to do things like add comma to your data, add dollar signs to your data, etc. And it's my go-to way for adding that information. So just adding it here. And then I'm not sure what I'm highlighting here, but here we go. And so then we have a heat map using both geome tile and geome text to add it on top of each other to represent our heat map. But you may be wondering, we went through the work to create a ggplot object. First, we had to tidy the data, then we had to, build our plot. But what if we already have a table and we don't want to go through all of that? And so in this example, right, like this looks great to us. We just want to add a heat map on top of it, similar to how you do in Excel. So this is where the GT package comes in. So like we mentioned before, GT is a package for creating tables using the various components and building on top of each itself. So we can start with our data and pipe it or pass it into GT. And we already have a nice table here. We wanted to add colors, so we can go add that data color. We can specify the columns that we want to add the color to and the palette or the colors that we want reflected in that data. And for the formatting of currency, we can use format underscore currency, specify the columns we want to format, and doing so. And then because we can continue building upon our table, say we wanted to add a title and a subtitle to kind of demonstrate what exactly 22.20 means, we can just keep adding to our table like so. Okay, so next up, we're going to talk about sparklines. And like I mentioned, sparklines are kind of minimal representations of variation over time, or some other variable, but usually over time, like so. And here we're going to use another data set that shows visitors to these national parks over time. For ggplot2, we can go back and create a line chart like we did before, and setting up our ggplot, adding our data, and then specifying geoline. But this isn't, well, it is very informative, but maybe we want to look at this information by park as opposed to overall how many visitors there are every single year. So for that, we're going to add something called group. And so specifying the park name, and that splits up the data so that we could see each one separately and like so. And this is great, but what if we want to see it kind of more individually, like you saw in the Excel example, where each park you can see its variation very, very clearly. So for that, we can add one more thing called facet wrap. And facet wrap just takes the park name and then creates individual boxes where within those boxes, you can see that particular part's trajectory over time. And so in terms of doing it in tables, I am going to introduce this package called GT Extras, created by an awesome colleague, Tom Hawk. And GT Extras is incredibly helpful in terms of the functionality it provides to add upon GT tables in a really fantastic and intuitive way. So again, let's go back and look at our GT table. And one thing about GT Extras is that it specifies how to work with data in a particular manner. So in the balance of flexibility and functionality, it goes with the functionality to be able to use it, and really understand how to use it regardless of the function that you're using in GT Extras. So all this to say, in order to create sparklines, first we have to create a separate list of all of our visitor data in its own separate way, but in the same row of the particular park that we're talking about. So a very quick summary of how that works. And then we use this function called GT plot sparkline and pass it our visitor list data, and we can create our sparkline. So I'm just going to go through the next three pretty quickly, because hopefully by now you can see like the capabilities of both ggplot2 and GT to just extend in the ways that you're interested in. Rep charts are also known as unit plots or dot plots, and they represent individual quantities or units depending on like the data that you provided. So instead of aggregating it all in a bar plot like this, you could see each one separately. For ggplot, we do this by introducing one more geom called geom.plot. And just really briefly, flips the coordinates of your ggplot, and we get something like this. From GT Extras, there is also the functionality to create these sorts of charts or with different units. So again, we provide our data to GT, and we can use this function called GTFA repeats and say, for the column that's cylinder, please use square icons. And so each one of these, represents 4, 6, or 8 cylinders like so. If we wanted to use something more representative of our data, instead of square, we could use car. For data bars, it's similar in terms of representing data alongside the number that you are interested in. And for ggplot, you could do this. This is our chart from before. We're going to flip the coordinates again to make it a little easier to read. And then we're going to add geom text again. If you notice here, we're going to say something called after stat count. And the reason for this is to provide the number of the count without having to calculate it beforehand. The ggplot2 has the functionality to do that, which is absolutely amazing. So different kind of statistics, you don't have to manually create it yourself. You can just put it within ggplot2. And that gives us our counts next to our bar plots, which represent the different quantities. And for GT, again, using GT Extras, we could go back to this chart, and we can use the function called GT plot bar to add the bar plot next to our data in a table. You can keep customizing it. You can keep adding different bars like so, and really just make it look exactly how you would like. And finally, icon sets. Ooh, hello? Oh, okay. Icon sets is adding icons next to your data to represent something like change or rank. And in terms of how to do this, again, GT Extras is absolutely amazing and has something that lets you do that using this function called GTFA rank. And I know we are quickly running out of time, but I hope that this was a good introduction in terms of all the things that you could do. Well, not all the things, a lot of things you could do with ggplot2, GT, and their family of functions. If you are interested in running this code yourself, I've included the script that you need to run in order to install all of these packages. One thing I wanted to mention is there's a tool called SQS, which is incredibly helpful if you want to create ggplot2s with a GUI. So some sort of interface that can help you pull data and the variables that you need and create a different kind of chart. Like so. And finally, if you're here, you might be interested in, outputting these things to Excel or, an email or things like that. There are certainly many ways of saving ggplot2 and GT outputs so that you can share it with the world. And that is what I have. Thank you so much.
Awesome, Isabella. Thank you so much. I think what I really liked about that was how it really showed like such a breadth of what is possible to do and such a variety of different things. As you were getting started, there was some feedback when you showed those diagrams of like, here are the tools that I've used in the past or I use now, and there was a lot of people being like, yep, that's the reality, like that is life, and like how do we deal with that, which was really great. I think there's a lot of thoughts in the chat as people were going along. I don't know if any of us here have expertise or if you've talked to anybody, but like, do you have any advice for people who are like working in Power BI and maybe like want to go from R to Power BI? Like, do you know of any good resources for that? Especially when it comes to tables or visualizations. I know I don't really, so I don't have a lot of advice. Do you?
Yeah. The thing that immediately comes to mind is at RStudio Conf last year, I certainly saw a talk about using R and Power BI and kind of like how they can interface and different like kind of best practices. But unfortunately, not really. Mostly what we would use is Excel.
Yeah. Nice. So that might be a good thing to look at if you're wanting to go from like make tables or like to look into for more details. There
I
was
have
some.
worked in Power BI, Julia.
Okay.
So
Oh, you have. Okay.
I
Okay.
have done R through Power BI. It works fantastic for visualizations. It can do data transformation. There was a question about the Power
Tables.
BI
Yeah.
back and forth. And that may have to come back as HTML or something like that. But Microsoft is heavily invested in R, and Power BI is a Microsoft product. And so you can embed R into Power BI to leverage all of those wonderful plots.
Yeah.
Yeah.
Nice. Some people asked about the base pipe. They saw you using the base pipe, and some people were like, "What is that? I haven't seen that," or anything like that. So I dropped a link to your blog post about the base pipe, but I didn't know if you wanted to comment or maybe say why you decided to use it or when you switched over, or like anything about using the base pipe.
Yeah, absolutely. Yeah, thank you for sharing that. And it took me a while actually to switch over. I think what really motivated me was I believe Hadley's recent blog post on why we're using the base pipe. But it's very similar to the Magritte pipe, the one that you may have seen before. There are some differences, especially if you're working in base R. But essentially, the native pipe is native to, and it's called native pipe because it's built into R, any R over 4.2, I believe, and very, very similar, especially if you're working within the tidyverse. And yeah, I'm also like sometimes like I try to exercise my base arm muscles and like switch over. And so that's another reason that I decided to use it.
Yeah. You showed such a variety of things here, but people did a couple of the comments were actually people asking for specific, what about this? What about this? And I don't know if
Oh,
you, off the top of your head, know anything about these or have what you would do, maybe if you wanted to look for this, even if it's not off the top of your head. I'll tell you both of them at once. So the first one is sunburst plots.
nice.
And the second one was what to do when you have something like time series data, like something changing over time, but also geographic data. Like it's for, say, for every state in the US, you have
Mhm.
something changing over time. Like how would you get that all in one plotter table or something like that? So those were the two that people mentioned. And I don't know if you have ideas off the top of your head of things you might try or look at.
Yeah, I don't know any Sunburst packages off the top of my head, but there is a ggplot2 gallery, and I'm almost certain I've seen that before. So I recommend just Googling a ggplot2 gallery and finding it there. And for the second one, the first thought that I have is there is a package called GeoFacet. And so for, say, each state in the US, it provides like a little box. And within those boxes, you can create individual plots. And there was a really, really interesting plot not too long ago about the percentage of folks in each state that were born outside of the United States, and you can kind of see the variation for each state just immediately in one chart. So GeoFacet is my recommendation.
Nice. Nice. And so you showed I'll grab the link so that we can put it in here again. But you showed that UI like interface for like generating ggplot code and all that. What in what situations do you think that is helpful or things that you might turn to that? What when do you think that's like a helpful thing to do?
Yeah. So that tool is called SQS, and sorry that I kind of blew by it, but another thing I forgot to mention is that it actually provides the code for the thing that you are creating. And so it is still code first, it's still reproducible. And I would turn to that, say, if like a geom like doesn't immediately come to mind, or you have some kind of starting to prototype different kind of graphs, and then getting to the point of like, this is the plot that I want, taking the code that is created from SQS back into your R script and really adding those customizations with themes and labels, etc. So that would be my recommendation, and especially like if you are interested in how to create a ggplot2 that you've never done before, like being able to see like, yes, this is what I want, and then analyzing the code so that you kind of internalize how to do it the next time.
Yeah. Awesome. Awesome. So I think that was all the questions and we're at an hour. So I always want to thank you again so much, Isabella, for preparing this, for sharing this. It was really nice, like this nice potpourri. It's like nice mix of like different things to be able to see, which was really interesting. And like folks in the chat are just really happy to have learned this. So thank you so much for doing this. For those of you who are here with us, we do plan to have a meeting next month. So we will get that announced on Meetup ASAP so you can plan and know where that is. And then like Alexa mentioned and invited us, if you're here in the Salt Lake area, save the date for that August networking session that we will have, which is going to be on August 17th, Thursday, August 17th. So save the date if you are local here with us. Thank you all again so much for coming, and we will see you next time.